Go ahead and sketch this graph. I thought it'd be easier to do a video. I know like the problem has videos, but I think just hearing it from me might be a little different, just as much resources as possible. So I do understand the question because piecewise functions are historically challenging for students because not only is it a function, but it's in pieces. So really, this is kind of interesting because in the real world, our behaviors that we look at are always in pieces. So when we first learned functions, we were taught about functions and then we're taught about domain. And now we're actually putting these two concepts together, right? We're putting a function together and the domain and what they mean. So in this case, what we're going to do is for every piece of f of x, we're going to graph it only on the restricted domain. So for f of x equal -3, x will be less than or equal to -1. So for all x less than or equal to -1, we'll go ahead and make the horizontal line -3. Now, notice here the endpoint of one piece is the beginning of another, and one is included and one isn't included. And that's due to the definition of a function and the fact that we could think about, oh, it has to pass the vertical line test. Well, if we include 2 points on two different pieces of a function, it won't pass, right? So one, you'll always see where one ends and one begins, one will be included and one won't. So let's just take the other endpoint of the second piece, which is 2. Notice it's included. So on the third piece where it starts, it's not included. And so that's really common, and that's exactly what we should be doing with piecewise functions. The next thing I want to note is that we want to just include closed or open dots, but only at the breaks. So if we see that this first piece starts where this begins, the second piece, then we really don't need a dot because we assume it's just continuing. But however, if it breaks and we see a jump up or down, then we'll use the dots to be clear. So let's go ahead and we'll graph first the lines and then we'll worry about the dots later. So for x equal -1, we have -3, a horizontal line. So let me do a partial line, which is this piece here. And it's nice because it's only half the line. So if you go to -1, -3 and graph, it pops up a whole line. So it's nice. And you just click on the endpoint. And then for 2x minus 1, it's between -1 and 2. So if I plug in the endpoint -1, I get 2 times -1 is -2. -2 minus 1 is -3. So notice that where this first piece ends is where this second piece starts. Therefore, it's continuing and we won't put a dot, but we'll just put a line segment. We're just doing a piece of a line, not the whole line. And plugging in the other endpoint 2, we get 2 times 2 is 4. 4 minus 1 is 3. So that'll be 2, 3. So let's do a line segment, which is this one, from -3, 1 to 2, 3. The third piece is f of x equals 1 for x greater than 2. So if I put 2, 1, it's a horizontal line, and this time I have to do the partial line here, and 2, 1, and then all the way out. Now let's go ahead and look at the dots. So we're only going to include the dots if there's breaks. And notice there were no breaks all the way through the first two pieces, but then we had jumps and a break at the third piece. So because 2 is included in the second piece, we'll do a closed dot at the end of the second piece, and then it's not included in the third piece, so we'll do an open dot on the beginning of that third piece. And that's what that should look like. And if you want to go ahead and submit, notice it says 1 out of 1. So that's what it's looking for. Not to worry though, I do go through all the quizzes with the graphs and I just kind of make sure to give credit where due, even if something's a little off. But at least this gives you a better idea how to graph the piecewise functions.